So we have brief introduction about the automation. What is automation? Automation allows your network task to be performed quickly and consistently, reducing the likelihood of human error. So here you can take the example. Right now we configured wireless network, right? So in wireless network, what happened? Initially, the access points you were manually going and configuring one by one. But when we use WLC, what happens? Gets centralized, automatic configuration. Okay. Same thing here. So it can significantly improve efficiency by automating repetitive tasks like configurations, backup, monitoring. Okay, with the help of automation, these things can be done efficiently. Okay, so automation enables proactive network management through real-time adjustments and optimization. Okay, now if we talk about the devices, so each and every device, they are having three planes. Okay, these planes, these are not physical, these planes are logical only. These are nothing but the functions. Okay, so what are these planes? We have data plane, we have control plane, and we have management plane. So what is the data plane? Data plane is about all the functions and processes which are forwarding the packets from one interface to another interface. For example, you take an example of a router. So what the router does, router will receive packets on one interface, then it will check the destination IP address in the packet, then it will see in the routing table how to reach that particular destination network, and then on the relevant interface, your router is going to forward the traffic. Correct? So these all features, receiving the packet, then deciding, okay, through which interface it has to forward, and then forwarding through the other interface. This is what these are the data plane features. Okay, so this is done by all the devices. Then we have control plane. Now, what is the control plane? Control plane controls the data plane functions. How? For example, a router, when it receives a packet, it will check the destination IP address. Then after, it will check the routing table that, okay, do I have a route or not to reach that particular destination network? So in the routing table, if there is a route, then only router will be able to forward. If there is no route in the routing table, then router will not be able to forward the traffic, right? So that means who is responsible for creating those tables? Who is responsible for creating the entries in the tables? It is your protocols, okay? So all the protocols and functions which are determining that which path to use, they are your control plane functions. Okay, they are your control plane functions. So all the configurational part is there. Okay, then management plane. So management plane is all about the functions that you use to access the device and to manage the device. You use it for monitoring and configurational purpose. So like, if I want to access a device, I can use telnet, SSH, HTTP, HTTPS. These all functions are what? These all functions are management plane. Okay. Now, normally in a legacy network, what will happen? That you individually go and monitor a device, configure a device. So individual device will have all these planes. Okay. But in a controller-based network, what happens? That your control plane gets centralized. And when I say control plane gets centralized, what does it mean? It means that all the configurational part gets centralized. For example, right now we use the WLC. So what is the WLC? It's a controller only, right? So all the configuration where we did it in the WLC. Down after that, your access points, they automatically took the configuration and they started forwarding the data. Okay. So these are the access points which are having data plane and management plane, data plane, management plane. But the configurational part was centralized. Where? In the WLC. So when you are using a controller, your control plane gets centralized. Okay. But again, the WLC also we were not directly accessing. Okay, I wasn't directly working on the WLC. I was accessing the WLC using a protocol like HTTP or HTTPS. right? I was using an application software. And this is where the architecture becomes what? Software defined network architecture or SDN architecture. Okay. So here what is there? That you have the network devices. Consider these as your lightweight access points. These network devices you manage via a control plane, which is your controller, like your WLC. And then you use certain applications to manage the WLC also, or the controller. Okay. So here if we see, we have two interfaces on the controller. Okay. If we talk about direction, so like this, we say north, this is south, then we have east and west. So the controller, it will communicate in two directions. This is the north direction. So this interface will be known as northbound interface. And this interface will be known as southbound interface. On the northbound interface, two applications will communicate. And whenever two applications will communicate, so the medium or the interface is provided by API, application program interface. Okay. And here the API that we mostly use is REST API, representational state transfer API. Okay. And on the southbound interface, two devices are communicating, and whenever devices are communicating, we use protocols. So here protocols like OpenFlow, NetConf, these kind of protocols will be used for communicating with the devices. Okay. So now understand here that what is SDN? SDN stands for Software Defined Network. Okay. And we have northbound interface as well as the southbound interface. On the northbound interface, API will be used. What is API? Application Program Interface. So API is a medium for two applications to communicate to each other. Okay. And the northbound interface is going to use the REST API to communicate to the controller. While southbound interface, it will use protocols like OpenFlow and NetConf to communicate with the controller. Your REST API is one type of API, and it will use C. API will just provide you the interface. For communication, you require a language. You require a data encoding method. And here we will use the JSON. JSON is the language REST API will use to communicate between two applications. And the actions that you can perform using the REST API is CRUD, which is create, read, update, and delete. That means you can create the configuration, you can read the configuration, you can update the configurations, and you can delete the configurations with the help of the REST API. And the network automation tools that you use for this is Ansible, Puppet, and Chef. Okay. Now this in CCNA also recently CCNA is going to get updated. Okay. From 20th August, your CCNA will come with some changes. So what are those changes? Your Puppet and Chef has been removed. Now you have Ansible only. Okay. Along with Ansible, they have given Terraform. Okay. Like what is Terraform? You have to know. Then after, one more small change is there, that now you don't have to know about the SDN. You have to know about like what is the role of AI in the networking. Okay. So this thing I have attached in this also in our curriculum. So right now what we are going is with the latest version, which will be updated from 1.1. Okay. From 20th August 2024. So what are the CRUD operations? CRUD operations are for create, read, update, and delete. These are the basic operations that can be performed via the REST API. Okay. And for this thing, it will use the HTTP verbs, or you can say HTTP messages. Okay. What are those messages? Get message to read the configurations, post message to create the configuration, put or patch message to update the configuration, and delete message to delete the configurations. Okay, so this is how it will be using. These are the methods which are used to perform the CRUD operations. And for data encoding, it will use what? JSON. Okay, so this is how your JSON data looks like. Okay, this is a JSON encoded data. So let's say I have to do the configuration of a switch. So in JSON, what happened? Your configuration is done in the form of key value here. This is a key and this is a value. Okay. So like what is the host name you want to set? Switch one. What is the interface? Gigabit Ethernet one. What is the IP address you want to set there? This is the IP address. This is the subnet mask. This is the default gateway. So like this in the key value format, you can configure the device. Okay. So you can use here JSON. This is a JSON encoded data. Okay. So now let's compare the Ansible, Puppet, and Chef. Although this is not there in the syllabus right now. So Puppet and Chef, even before also we were not really using them. Why? Because they are having agent-based architecture. That means you need to install an agent software in your routers or your devices. Okay. And those agent programs, those are not really working very well with the Cisco devices. Okay. So in case of Cisco and in case of network automation, we mostly prefer Ansible. Why Ansible? Because Ansible has an agentless architecture. Okay. And all your Ansible requires is that your device must support SSH, and all devices are supporting SSH. And that is the reason that with the help of Ansible, we are able to perform the automation. Okay. And in the new version, like I said, Puppet and Chef has been removed. So here Terraform has been attached. So if we talk about the few differences about Ansible and Terraform, so Ansible is a configuration management tool, while your Terraform is an infrastructure as a code service. So it is for cloud deployments. Okay, if you want to deploy in the clouds. Then here it has an agentless architecture. Ansible does not require any sort of agents. Your Terraform requires agent to be installed. Okay, your Ansible uses YAML and Terraform uses dedicated language, SCL, HashiCorp configuration language. This HashiCorp is the organization which has created or developed this Terraform. So what is the primary use case for Ansible? Configuration management and application deployment. And Terraform when used is what? Provisioning and managing the infrastructure on the cloud. And if we talk about support for network devices, Ansible is supported in Cisco, Juniper, Arista, almost all the devices. While the support for Terraform is limited, not all the vendors, they are supporting it, and it is mainly focused on the cloud resources only. Then if we talk about cloud support, so Ansible is also supported in the cloud. Okay, it has modules for AWS, Azure, GCP and all. And same thing is there for the Terraform also. State management, so there is no built-in state management in case of HCL, but Terraform will track the state of your infrastructure. Okay. So your Ansible has very simple syntax and it is very easy to start with. For it. Terraform, you need to learn the language HCL. Okay. So it requires the understanding of HCL and state management. Then Ansible has been there for a long time. So there is a large community and active community with many modules available. While Terraform also has a large and active community with providers and modules. Okay. And what are the example uses? So Ansible can be used for automating configuration changes on the network devices. And Terraform is generally used for provisioning and managing your cloud resources. Okay, if you want to deploy any, you can say if you want to deploy any virtual machines on the cloud and all. For that reason, your Terraform is used. Then after, if we talk about, what is the AI and machine learning in the network operation. So right now, AI has been introduced everywhere. Okay, recently within last 1 or 2 years, it has been there. So what is the role of AI? So AI-driven automation for predictive maintenance and anomaly detection. So AI is helping you, and also it is, improving our efficiency into detecting the anomalies and responding to the threats. And it also enhances network security and performance. So we have two types of AI, generative AI and predictive AI. Generative AI is going to create new data based on the patterns. While predictive AI, what it does, it predicts the future events based on historical data. that, okay, this is how the network is going on. So it will predict the state of upcoming future. Okay, so like it will give you introduction that, okay, in future you might need these many resources, you might need to upgrade your this thing, that thing. Okay, that kind of information it will give you. Then if we talk about use cases, so AI and machine learning, this can be used to analyze your network traffic for threat detection and capacity planning. So example, you can say that predictive maintenance, like the predictive AI that can give you information about that, okay, this particular router has a possibility to fail. Okay, this particular router has a possibility that in coming future it might consume entire bandwidth, or the CPU uses will be high, so this device might go down. Okay, that kind of thing. So predicting hardware failures and preemptively replacing the components, and also for anomaly detection, like identifying unusual patterns in the network traffic that may indicate a security breach. So in these ways, we can integrate your AI and machine learning in the network operations. There are certain benefits also, like they will improve your network reliability and efficiency, as well as they will reduce the downtime and enhance the security of your network. Then there are certain tools you can talk about: Cisco's AI for network analytics and IBM Watson for cybersecurity. These are some tools which are there for the network operation, which include your AI and machine learning. But with AI and machine learning, we do have some challenges also. Like we have data privacy concerns, because AI will be looking over your all data. And also it will need for large data sets for accurate predictions. That means AI has to look over a huge amount of information, huge amount of data, huge amount of logs to predict anything very accurately. Otherwise, sometimes it might give you incorrect information also. Okay. Then after, if we talk about, overlay, underlay, and fabric. So first of all, what is underlay network? Underlay network is your physical infrastructure. Okay, the physical infra over which your overlay network is going to run. What is the overlay? So overlay is like, your virtual networks like VPNs, which are running on your physical infra. So your underlay network will provide you routing and connectivity services for the overlay. And what is overlay? It is a virtual network that is built on top of your physical network. And your physical network is what? Underlay. So this facilitates your network virtualization and can be used to deploy your logical segments like VPNs. Now in the data centers, we use a different architecture, which is your network fabric. So a fabric is what? A flexible and efficient architecture that connects network nodes and often used in the data centers. And your network fabric will utilize both the things. It will utilize your underlay as well as your overlay to deliver highly scalable and agile network solutions. Okay. Then after about software-defined architecture. So for performing automation on the LAN side and WAN side, in Cisco, we have two solutions. Okay. So for LAN side automation, we have SD access, and for WAN side automation, we have SD-WAN. Okay. So Cisco's SD-WAN is known as Cisco Viptela SD-WAN. Initially, the SD-WAN solution was designed by the Viptela company. Cisco acquired it, and it became Cisco Viptela. Okay. So if we talk about SD-WAN, SD-WAN is used for automation on the WAN side. Okay, internet or ISP side automation. So they will have devices like vManage, vSmart, vBond, and vEdge. So vManage is the manager where you'll do all the configurations and everything. Okay. And vSmart is responsible for delivering that configuration to the edge device of the customer. Okay. This vSmart will be responsible for delivering the configurations to edge devices. And your vBond, it is responsible for centralized authentication. Okay, so first of all, as soon as your edge device will come up, it will authenticate itself with the vBond. Once authenticated, now it will have communication with the vManage and vSmart, and they will be delivering the configurations. And for LAN side automation, we are using SD access. So in SD access, we have the controller, which is DNAC. Okay. And for centralized authentication of your entire LAN network, we have ICE, Identity Service Engine. Okay. And for discovering the changes in the network, we have NDP. Okay, so let's understand this thing. What is WAN? WAN is a collection of LAN. So your SD-WAN is a technology, and Cisco has named its SD-WAN technology as WebTel. So SD-WAN is used to manage the devices at the WAN side. That means SD-WAN is used for automation on the WAN side. And in SD-WAN, we have terms like vManage, vSmart, vBond, and vEdge. And in case of SD access, so this is a technology that is used to manage the devices at the LAN side. And it is used for automation at the LAN side. And here we have DNAC, which is Dynamic Network Analysis Controller. ICE, which is Identity Service Engine, providing centralized authentication. NDP, Neighbor Discovery Protocol Engine, which is identifying the changes in your topology. Any new device is added or removed. So all those changes will be taken care by the NDP. And DNAC is the controller where you will do all the configurations. Okay, and from where you will manage your entire LAN network. Okay, so this was a very small introduction about your automation.